In general, it's a good idea to always declare variables as constant if they don't need to be modified, because this makes sure that they won't be changed anywhere in the program by mistake, which in turn helps to prevent bugs. A variable in C++ can be made into a constant by adding the const keyword either before or after the data type. This modifier means that the variable becomes read-only, and it must therefore be assigned a value at the same time as it's declared. Attempting to change the value will now result in a compile time error. When it comes to pointers, const can be used in two ways. First, the pointer can be made constant, which means that it cannot be changed to point to another location. And second, we can declare that the pointee is constant. This means that the variable pointed to cannot be modified through this pointer. It is also possible to declare both the pointer and the pointee as constants to make them both read-only. Note that the constant variables may not be pointed to by a pointer to a non-constant type. This prevents us from accidentally rewriting a constant variable using a pointer. References can also be declared as constant in the same way as pointers. However, since reseating a reference is never allowed, declaring the reference as const would be redundant. It only makes sense to protect the referee from change. Just as with variables, pointers, and references, objects can also be declared as constant. This not only prevents us from accidentally reassigning the object to another instance, it also prevents us from changing the fields that the object contains. Because of this restriction, a constant object may not call a non-constant method, since these methods are allowed to change the object's fields. They may only call constant functions, which are methods that are marked with a const modifier just before the method body. This const modifier means that the method is not allowed to modify the state of the object and can therefore safely be called by a constant object of the class. More specifically, the const modifier applies to the this pointer that is implicitly passed to the function. This effectively restricts the method from modifying the object's fields or calling any non-constant methods in the class. Note that in addition to making the method constants, the return type and method parameters may also be made read-only. For example, if we wanted to return a field by reference instead of by value from a constant function, we must make sure that it is returned as a constant in order to maintain the constantness of the object. Note that not all C++ compilers will be able to catch this subtle mistake. Static and instance fields in a class can also be declared as constant. A constant, non-static field must be assigned its value using the constructor's initialization list. This is the same as the preferred way of initializing non-constant, non-static fields. A constant static field, on the other hand, must be defined outside of the class declaration, the same way as with non-constant static fields. The exception to this is if the constant static field is of an integer data type. Such a field may also be initialized within the class at the same time as the field is declared.